Before we investigate the statement, it's vital to handle the meaning of what's in question. The Large Hadron Collider, LHC, operated by CERN, marks a fantastic accomplishment in scientific advancement. Spanning 17 miles, this modern array of superconducting magnets stands as the largest and most powerful atom smasher ever created. It serves as a symbol of human creativity and the remarkable achievements we've made in understanding science. Amazingly, the LHC is capable of recreating the conditions that existed at the very beginning of the universe. However, as we venture into the cosmic unknown, a crucial question arises. Could this machine, which aims to uncover the universe's deepest secrets, also expose us to unforeseen dangers? The role of CERN and the LHC. Founded in 1954, CERN is one of the world's most respected scientific institutions, with 23 member nations and a vast community of researchers. It serves as a hub for collaborative research and groundbreaking discoveries. Although the LHC is its flagship project, it is just one part of a vast network of particle accelerators and experiments. Think of it not as a circuit for cars or horses, but as one for subatomic particles, engaged in a high-stakes race to test the limits of speed, precision, and the very essence of existence. Inside the LHC, protons are accelerated to nearly the speed of light, mimicking the energy levels that were present at the moment of the Big Bang. The resulting collisions reach temperatures far greater than the core of the Sun. A system of magnets directs the protons along their paths, while advanced cooling systems maintain the magnets at temperatures colder than space. These collisions are deliberately arranged at 4 distinct points within the accelerator, where specialized detectors, ATLAS, CMS, ALICE, and LHCb, collect data. Each detector has a unique function, offering different perspectives on the aftermath of these high-energy impacts. Together, they act as colossal cameras, capturing the wreckage of these collisions. Scientists meticulously examine the debris to identify elusive particles like the Higgs boson, often referred to as the God particle, and other phenomena that could shed light on the fundamental building blocks of a universe. By focusing on subatomic particles, researchers aim to understand the very structure of reality itself. The LHC, a marvel and a mystery. With each new discovery at the LHC, even more questions arise. The collider isn't just a machine. It represents humanity's relentless curiosity and our persistent quest for knowledge. It embodies our desire to grasp the forces that shape our reality. Yet, as we push the boundaries of the unknown, we must confront the ethical and existential dilemmas that come with it. What dangers could emerge from probing the unknown? Could our pursuit of knowledge unleash forces beyond our control? At CERN, where the limits of human understanding are being stretched to the extreme, an unsettling realization has surfaced. One that has unsettled even the most seasoned scientists. A chilling revelation. Brian Cox, a former CERN researcher and a highly respected figure in particle physics, recently made a chilling statement that has both fascinated and alarmed people worldwide. Cox revealed that the LHC's purpose is to simulate a miniature version of the Big Bang, essentially, a tiny Big Bang. He elaborated on the enormous potential of the LHC to unlock groundbreaking discoveries, such as unraveling the mysteries of dark matter, a substance that makes up a significant portion of the universe. The possibility of harnessing the fundamental forces of the universe is undeniably thrilling, but it also comes with significant risks. The miniature Big Bang isn't just a theoretical concept, it is a real phenomenon that occurs within the LHC. The collider recreates conditions of extreme heat, pressure, and energy, mirroring the environment at the universe's birth. Perhaps we are witnessing the birth of time itself. However, with such immense power comes tremendous responsibility. What if something goes wrong? A grim reminder. The Anatoly Bugorsky incident. This concern is not new. In 1978, Russian physicist Anatoly Bugorsky had an experience that forever changed the course of his life. While working with the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia, a malfunction caused a proton beam to unexpectedly cross his path. The beam, traveling at unimaginable speeds, pierced his skull, entering from the back and exiting through his nose. Struck by a flash of light brighter than 1,000 suns, Bugorsky remained conscious and sought medical attention. The aftermath was both astonishing and terrifying. He lost hearing in one ear and suffered partial facial paralysis. Yet, despite the severity of his injuries, his cognitive functions remained intact, and he continued his scientific work. Bugorski's experience serves as a grim reminder of the power and potential dangers associated with particle accelerators. The LHC and the black hole debate. The risks of machines like the LHC should never be underestimated. Some scientists have raised concerns about the possibility of unforeseen reactions that could alter the very fabric of reality. For example, there are fears that the LHC could create a miniature black hole. Black holes are regions of space where gravity is so intense that not even light can escape. These devastating forces exist at the edges of the universe, and the idea that the LHC could create even a tiny black hole is both awe-inspiring and terrifying. Could such a black hole grow uncontrollably, eventually consuming the Earth from the inside out? CERN researchers have attempted to reassure the public, asserting that any black hole formed within the collider would be extremely unstable and would disappear almost instantly. Still, the remote possibility of such an event has sparked widespread debate and concern. To understand how the LHC could create a black hole, it is essential to grasp the fundamental mechanics of a particle accelerator. When protons collide at nearly the speed of light, the energy released is so immense that it can warp the very fabric of reality. Imagine a tightly stretched trampoline with a heavy object dropped onto it. The fabric bends, and if the object is heavy enough, it can create a depression deep enough to pull anything nearby into it. This analogy offers a glimpse into what the LHC might do to spacetime at a quantum level, where the laws of physics become unpredictable. Exploring extra dimensions. One theory suggests that extra dimensions, beyond the familiar 3 dimensions of space and one of time, could exist. If such extra dimensions are real, the LHC could have the ability to access them, potentially forming a gravitational well that leads to a small black hole. This possibility has drawn the attention of renowned physicists, including the late Stephen Hawking. In his writings, Hawking warned that the Higgs boson could become unstable at extreme energy levels, possibly triggering catastrophic events, such as vacuum decay. Sir Martin Rees, a distinguished astrophysicist, also raised concerns about the LHC's experiments. In his book on humanity's future, Rees acknowledged that while the odds of such an event were low, even a small probability warranted serious consideration. The future of the LHC, pushing boundaries with caution. The stakes are incredibly high, and the margin for error is razor-thin. CERN scientists have conducted numerous simulations and studies, taking every precaution to ensure the safety of their experiments. Brian Cox himself has addressed concerns surrounding the LHC, emphasizing that strict safety protocols are in place. According to Cox, the energy levels involved in LHC experiments are far lower than those that naturally occur on Earth. Even if a black hole were to form, it would be so small and unstable that it would quickly dissipate, releasing energy in a burst, as predicted by Hawking's theory of radiation. Some have speculated that the LHC's experiments could open a portal to another universe or dimension. Although mainstream scientists largely dismiss this idea, it has captivated the public's imagination. But what if they are right? What lies beyond our universe? Unintentionally releasing powers or substances we don't completely fathom is a daunting thought. The idea of equal aspects is definitely not just another string hypothesis. A main contender for a unified theory of everything proposes the existence of more than the 4 dimensions we experience, 3 of space and 1 of time. These extra dimensions may be hidden from our senses, yet under extreme conditions, they could theoretically be accessed. Imagine the LHC as a key, unlocking doors to realms that have remained concealed since ancient times. When protons collide at energies previously unheard of on Earth, they could create ripples that test these hidden dimensions. While this remains speculative, it highlights the allure of the unknown. The potential discovery of other dimensions continues to captivate the public, even though most scientists remain skeptical that the LHC will open a gateway to another universe, or something far more alarming. Should we be concerned about the risks associated with the LHC? It's easy to get caught up in sensational headlines and fears of cosmic catastrophes. However, the reality is that scientists at CERN are fully aware of any potential risks and have taken every precaution to ensure the safety of their experiments. They constantly monitor and assess their work with the highest level of diligence. The expected benefits of their research, such as unraveling the mysteries of dark matter, discovering new particles, and deepening our understanding of the universe, are truly remarkable. These breakthroughs represent a significant leap forward in human knowledge. However, like all groundbreaking scientific advancements, the experiments conducted at the LHC raise important ethical questions. Could the creation of exotic particles or the exploration of extreme energy conditions lead to unforeseen consequences for our planet, or even the very fabric of reality itself? These questions cannot be ignored and must be carefully considered in the broader context of scientific progress. The Large Hadron Collider is a monumental achievement of human ingenuity and curiosity. It has already led to groundbreaking discoveries in particle physics, shedding light on the fundamental workings of the universe. Yet, as we explore these mysterious territories, we must remain vigilant and mindful of the potential risks involved. The pursuit of knowledge is one of humanity's most ambitious endeavors, but it is not without challenges. The LHC stands at the cutting edge of scientific exploration, where theory meets experimentation, and where the foundations of our understanding of the universe are being tested. The journey of discovery is never without risk, and the LHC is no exception. It pushes the boundaries of physics, seeking to reconcile the fundamental forces of nature and answer age-old questions about the origins of mass and the nature of dark matter. However, as we continue to explore these frontiers, we must consider the profound ethical and existential dilemmas that arise from manipulating the forces that govern the universe. The risks of unforeseen side effects, whether for our planet or the very fabric of spacetime itself, remain a challenge that demands thoughtful reflection. Nevertheless, the pursuit of knowledge remains one of humanity's most noble undertakings. The LHC's experiments, while risky, offer us a glimpse into vast, unexplored domains of science. As we stand on the brink of discovery, we must approach this journey with both ambition and caution. The LHC represents not only the pinnacle of human technological achievement, but also a powerful tool capable of reshaping our understanding of everything, from subatomic particles to the grandest cosmic phenomena. With each advancement, new questions arise, opening fresh avenues for exploration and contemplation. The path of scientific discovery is uncertain, yet it holds the promise of revelations that could redefine our understanding of the universe, our place within it, and the very laws that govern reality. One of the most profound aspects of the LHC's research is the intersection of theory and reality. For decades, physicists have grappled with understanding the forces that shape the universe: gravity, electromagnetism, the weak nuclear force, and the strong nuclear force. The ultimate goal has always been to unify these forces into a single, powerful framework, a theory of everything. The LHC has played a crucial role in providing experimental evidence and insights that bring us closer to this elusive goal. Its work not only enhances our understanding of particle physics, but also holds the key to uncovering the fundamental truths of existence itself. The ethical dilemmas tied to these experiments are significant. The pursuit of knowledge has always carried risks, but when those risks involve altering the very fabric of reality, the stakes become infinitely higher. Could a single experiment at the LHC inadvertently trigger an event we do not fully understand, leading to consequences beyond our ability to predict? This is a question that scientists, philosophers, and ethicists continue to explore. As we venture into these uncharted territories, we must remember the responsibility that comes with wielding such immense power. Despite the potential dangers, few would argue against the pursuit of scientific progress. The rewards, new technologies, medical advancements, and a deeper comprehension of the universe are enormous. The discoveries made by the LHC thus far have already transformed the scientific landscape, from identifying the Higgs boson to advancing our understanding of dark matter. These achievements have far-reaching implications, not only for physics but also for numerous disciplines that rely on this foundational knowledge. As we continue pushing the boundaries of possibility, the LHC serves as a reminder that science is never without uncertainty. No exploration is entirely without risk, and the LHC, though grand and powerful, is no exception. However, with each risk comes the potential for extraordinary discoveries. The LHC embodies humanity's relentless pursuit of knowledge, our mission to answer the questions that have puzzled us for centuries. Ultimately, this curiosity drives us forward, the desire to understand the universe, to peer into the depths of existence, and to uncover the forces that govern everything from the tiniest particles to the largest galaxies. The LHC may carry risks, but it also represents the pinnacle of human achievement in particle physics, a tool that enables us to explore the most profound questions about existence, challenge the very laws of nature, and seek answers to mysteries that have eluded us for millennia. Whether the LHC will lead to the discovery of new dimensions, open portals to parallel universes, or trigger unforeseen phenomena remains uncertain. What is certain, however, is that it is one of the most powerful instruments ever created, capable of unlocking secrets about the universe that were once thought to be beyond our reach. The potential for discovery is limitless. As we journey further into the unknown, we are reminded that science is an ongoing quest, one that demands both courage and responsibility. The experiments at CERN continue, and we must remain alert to the possibilities, the risks, and the vast potential for new understanding that lies ahead. The LHC, while representing the cutting edge of modern science, also reflects our deeper quest for meaning and understanding in an immense and mysterious universe. Every new discovery brings us closer to a more complete comprehension of the forces that shape our reality. As our understanding of particle physics expands, so too does the scope of questions we must confront. The LHC, while a technological marvel, is not merely a machine, it is a gateway to a deeper comprehension of the cosmos. Each particle collision, each data point collected, is a step toward unraveling the fundamental structure of reality. One of the most intriguing possibilities raised by LHC research is the potential discovery of supersymmetry, a theoretical framework suggesting that every known particle has a yet undiscovered, heavier counterpart. If confirmed, supersymmetry could bridge the gap between quantum mechanics and general relativity, providing a more unified description of the universe's fundamental forces. The discovery of such particles would not only revolutionize physics but could also have profound implications for cosmology, shedding light on the composition of dark matter, a mysterious substance that makes up nearly 85% of the universe's mass. However, the pursuit of such knowledge also forces us to grapple with the limits of human understanding. Are there questions we may never be able to answer? Could our perception of reality itself be constrained by the very physics we seek to uncover? These are not merely scientific questions but philosophical ones, challenging our assumptions about the nature of existence. Beyond fundamental physics, the LHC has also spurred advancements in technology and engineering. The computational power required to analyze the vast amounts of data produced by high-energy collisions has driven innovations in artificial intelligence, machine learning, and data processing. The same algorithms used to sift through trillions of particle interactions at CERN are now being applied in medicine, finance, and other fields, demonstrating how fundamental research can lead to practical applications far beyond its original intent. Yet, as with all scientific endeavors, the LHC's experiments raise ethical considerations. The idea of humanity wielding such immense power over the fundamental building blocks of nature is both awe-inspiring and sobering. While the risk of catastrophic outcomes remains exceedingly low, the mere possibility of unintended consequences forces us to continually question the boundaries of scientific responsibility. History has shown that scientific breakthroughs often come with unforeseen consequences. The discovery of nuclear fission, for instance, led not only to clean energy but also to the development of nuclear weapons. Similarly, the LHC's experiments, while designed to enhance our understanding of the universe, may yield results that challenge our ethical frameworks and force us to reconsider our role as stewards of scientific progress. Looking ahead, CERN and the global scientific community continue to push the frontiers of knowledge. Plans for even more powerful particle accelerators, such as the proposed Future Circular Collider, FCC, aim to explore physics at even higher energy levels. If built, this next-generation collider could provide answers to some of the deepest mysteries of the cosmos, from the nature of dark energy to the fate of the universe itself. Yet, as we stand on the precipice of these discoveries, we must ask, what is the ultimate goal of our pursuit? Is it merely to satisfy human curiosity, or does it serve a higher purpose? Some argue that understanding the fundamental laws of nature brings us closer to deciphering the very essence of existence, while others caution that such knowledge, if misused, could have unintended and irreversible consequences. Regardless of these philosophical debates, one thing remains certain: the LHC represents the pinnacle of human ingenuity and ambition. It embodies our relentless drive to seek answers, to challenge the unknown, and to push the boundaries of what is possible. Whether it leads to new dimensions, groundbreaking discoveries, or even more profound questions, its legacy will be one of curiosity, innovation, and the eternal quest for understanding. As the LHC continues to operate, colliding particles at unimaginable speeds, it reminds us that science is not just about answering questions, it is about asking the right ones. The journey of discovery is never complete, and each breakthrough paves the way for new mysteries to explore. In this ever-expanding quest for knowledge, we must balance ambition with caution, curiosity with responsibility, and exploration with ethical reflection. For as long as humanity exists, we will look to the stars, to the fabric of space and time, and to the very particles that make up our being, searching for meaning in the vastness of the unknown. And perhaps, in the collision of protons deep within the LHC, we may find a glimpse of the answers we have sought for centuries.